Wait a minute. Any problem? Okay, no. ఎంతంతే Okay, we'll start now. Some problem in the other mobile for chatting. I rebooted it. Okay, I'll start. I can't ask question now because unless I get the connection here, I can't ask anything. Playing like anything. Oof. Just a minute, it will come now. This way it acts. Okay, got it. Voice clear? Is the voice clear? Fully audible? Full audible? Fast? Okay. Clear. Charging clear? Okay. Charging is done. Okay. Yesterday's question. See, I wrote the plan once again. Already written. Left side projection 1.6 meter. Right side projection 2.2 meter. Both are from center of column. Column dimension is not required here. This is 5.4 meter and total length is 9.2 meter. Width is 1.95. Now, as usual, I will call this as this point. See, now ABCD I won't write because later when I put SFD BMD, I am going to call usual, you know it, where supports are there A and B, extreme ends are C and D. Actually, it is not a rule. Nobody can tell that way. I am maintaining that from beginning of my class. So, what I will do is, I will call this as 0.1, 0.2, 0.3 and 0.4. I will call this as, just a minute. ನನಗೆ ಅದು ಹಂಗೆ ಹೇಳುವಾಗ ಇಲ್ಲ ಹೇಳೋಕ್ಕಾಗೋದಿಲ್ಲ. ಇವೆಲ್ಲ ಕರಿತಾನೆ ಮತ್ತೆ ಕರೀದಿಲ್ಲ ಹೇಳೋತ್ತಿದ್ದೆ. I'll call points 1, 2, 3, 4. See, if you want, I'll round off 1, 2, 3, 4. Just for a change. Because later, for SFDBMD, lengthwise I want ABCD. Because usual habit. Okay, start. Now, complete force system replaced by a single load and one lengthwise couple and other widthwise couple. This is thoroughly explained for you for raft with 4 columns. Only 2 columns are here. Anybody who tells difficulty, he should go back to the earlier class. I think last week Sunday class, I concluded there by exactly considering same thing but 4. Otherwise, if anybody knew he is not interested in old classes, I will tell leave my class, don't come to my class. Okay, start. See, 1100, 1400. Somebody in the road will tell you 1500 kilonewton. Here also, if you see lengthwise, you can see actually loads are acting perpendicular. This is front view. This is the front view. So, you are seeing footing actually is like this. If this is not known, then why you want structural engineering first of all? Someone will tell, sir, load, how that load suddenly become this way. Then don't study structural engineering. That's all. This is plan. In the plan, loads are acting perpendicular. Okay, start. Here also 1500. And remember, now, lengthwise couple I want. Correctly come to center. Anybody can tell me what is central distance first? What is distance from here to here and here to here? Total 9.2, 4.6 meter. This also 4.6 meter. See here. Widthwise, this is 1.95. Both of them are this too much of depending on calculator. What to do? Nowadays, if somebody asked 4 into 17, how much? 4 into 17, I know it actually. Too much depending on calculator. People have become slave of calculator. 0.975 meter. 0.975 meter here. 0.975 meter here. Okay, now start. You should work out and get the answer. I will give direct couple. See, if you want, remember 1100 is acting here. See, 1100 is acting here. 1400 is acting here. 400 and lengthwise 100 kN meter couple is acting here. I want to put unit here. This way, anti-clockwise, 140 couple acting here. All of them bring here. When you bring here, see, anti-clockwise of 1100 into this distance. Clockwise of 100. Look this side. Clockwise of 1400 into this distance. Don't ask me what is this distance. Then anti-clockwise 140. Anybody can tell? All together replaced by a single couple. See, this is replacement. This is the replacement. Answer fast. Checking is not required. No, I want the replacement answer. How much? It is 1100 into bracket 4.6 minus 1.6 is anti-clockwise. Then 100 clockwise. Then clockwise of 1400 into 4.6 minus 2.2. And lastly, anti-clockwise 140. Is it 20? Oh, very small. Is it only 20? Oh, yes. So, therefore, remember, it is, 1 minute, direction required. Direction. 20 clockwise, correct? 20 clockwise. You make a note here. It is 20 kilonewton meter clockwise. See, very, very small equivalent couple came. Anybody can tell what is the reason for getting such a small couple? Anybody can tell? That is actually very, very good. See, when you replace this full force system by a single force and couple through center, if the couple comes very small, it is a very good news. Tell why? Reason. Why it is good news? Fast. Tell me common sense. Why it is good news? No, what is the reason? Oh, okay. That is print mistake. 2500, okay. Why it is good news? Anybody can tell such a low moment, why it is good news? Some will tell because of moment now, pressure will be very small. No, not that one. What it indicates, when you replace by this way, what it indicates? Make a note. It is actually very good. Very difficult to achieve. Sometimes difficult to achieve. But here, fortunately came. Anybody can tell reason or why it is good news? Why no answer? Why it is good news? No, not that way. Resultant column, complete system, the resultant load, if you see lengthwise, will almost coincide with CG of footing. Tell me, stability point of view, are you happy if the resultant load passes through CG of the footing or quite eccentric? Tell, when you are happy, when the stability feeling will come. When stability feeling will come, when the resultant load comes through CG or outside. Happy, that is the reason. Or you can make a note. If you go to the basic approach by finding X bar, shall I tell you X bar how much will come? X bar from here will come clockwise 20. Okay. X bar will come very, very small. 25. You calculate. It will come 0.9. When you find X bar here, 1 minute here. 4.608 meter it will come. If you go for the basic theory, from here resultant line will pass what it tells. See, 4.6, 0.008 meter, it will shift that side. Means what? It is that 0.008 into 2500 will give clockwise moment of 20 kN meter. So anyway, leave it. It is a byproduct. We fortunately got it. Okay, start. Widthwise, it will be equal to, see now, very simple. See, 1100 is acting here only. 1400 also is acting here only. So, moment these two loads from this way will not create moment. Only moment will be anti-clockwise 45, clockwise 75, will be clockwise of 30 kilonewton meter. Actually, this will tell you the pressure variation is very small for the corners, or it is a case of almost uniform pressure. It is a case of almost uniform pressure. Remember, how this answer came, I will not explain. Go back to class number, I don't know. Not yesterday, today's class is number what? Who will remember class numbers? Today's class is class number 38. Go to class number 36 of ETABS&SAFE or go to footings part 10. I think part 10, 10 or 12. I don't know. 2 class earlier. See there. I completely explained. Not 2 columns. With 4 columns. So those who are serious, they should have no difficulty. So those who are hardworking, sincere, is the result fully clear or not? Fast. For those who are sincere and hardworking or dedicated, or they want to learn from me in this class. Fully clear? Clear? Yes, sufficient. See, those who are hardworking and dedicated, for them clear means my purpose is served. People who are lazy, they cannot do anything, or lazy natured, who bothers about them first of all? Lazy people has no entry to, there is no consideration from me for them. Okay, now, I will remove everything now. See, all I will remove. I will put one more sketch now. See, 1 minute. I will put one more sketch. Okay. It is not required. See, I saved some time by writing that sketch. Now, see, therefore, if you see the combined footing without bothering beam type or slab type, you never bother that one. Corner 1, corner 2, corner 3, corner 4. Okay, now these are the 4 corners. Start. This is axis is called 2, 2. Oh, there is question here. There is 1, 2, 3, 4 is there. Okay, what to do? I will do one thing. I will put this one without rounding off. I will call that 1, 2. This 2 is not this 2. This is our earlier. You can take A, B, C, D, but confusion. That's why 1, 2, 3, 4. This is the corner name. Rounded is the axis. Rounded axis 1, 1. This is plan. There is a perpendicular load P here and one lengthwise couple and one widthwise couple. We got both clockwise. See, this is the couple about 2, 2 axis. M2. This is M1. Your M2 came 20 kilonewton meter. M1 came, so fast forgetting. If I forget this way, see, it happens. 30. Okay, 30. What to do? I am always that way. I forget within no time. See, all those projections, now I forgot. I have to ask you once again that left projection, right projection. Okay, you will tell. And remember, your P equal to 2500 kilonewton. Perpendicular plane. Now, without bothering anything, calculate PG maximum. Write the formula. Also calculate PG minimum. Write the formula and get it. If you substitute there, plus 1.1, 1.1 into 2500, here also into 2500 or 1 meter, PG maximum, divide by, this width is, if I remember, it is 1.95 meter. That is your L2. This length is, if I remember correctly now, it is 9.2 meter. 9.2 meter, L1. Divided by what? 9.2 into 1.95. Then, when you want maximum pressure plus M1, how much? 30 divided by how much? For M1 divided by 9.2 into 1.95 square divided by 6 plus M2 20 divided by 1.95 into 9.2 square divided by 6. Tell me the maximum pressure in Kn per meter square. Fast. First tell me the maximum pressure. See, we kept a margin of around 30% excess. I think 30% excess is not required. Tell reason. Anybody can tell that 30% excess area actually is not required because that is for the additional pressure due to M1, M2. But here, M1, M2 are very small. If you see there, these numbers will come very small. Or to understand, you give splitwise answer. To understand, you give splitwise answer. See, give splitwise answer. See, 1.1 into 2500 divided by 9.2 divided by 1.95. It is plus 153.289 plus 30 into 6 divided by 9.2 divided by 1.95 square is only 5.145 plus other one 20 into 6 divided by 1.95 divided by 9.2 square is 0.727. Means the pressure due to axial force is so predominant that excess pressure is very, very small. See here, the excess pressure is 5.145 plus 5.145 plus 0.727. And if I divide by 153.289, it is only into 100. Only 3.8% more. See, the excess pressure or additional pressure due to M1, M2 total together is only around 3 point, how much? 3.8%. How much I got? Okay, 3 point, I forgot now. 3.8 or around 4%. But see, only 4% more. But when you fix the column footing dimension, we are not knowing all these things. We do not know. Resultant can go that side, too much it may shift. If resultant shifts too much, pressure will come more. So keeping in mind, we have taken 30% more. So that 30% more is not required. If you want, you can reduce. Clear? If you want, of course, subject to SBC check is there. Okay, if you want, you can reduce. Tell the answer, how much it is? 153.289 plus 5.145 plus 0.727. That is 159.161 kilonewton per meter square. That is less than SBC of soil. That is how much? 200 kilonewton per meter square. Therefore safe. Yesterday I received an answer. I think 159 is not there. I don't know. Maybe some slight error. Don't comment. If you comment, people will think, people will know who has done it. Don't comment. I think don't comment. If you comment, people will know who has done it. So I saw different answer, but I not checked it. Now I checked it. Oh, sorry. Correct. M1 is 30 only. M2 is 20. See? No. See there. Lengthwise moment is M2. About axis 2. This is correct. How M1 20? See, axis 1 is here. This is the axis 1. So this is your M1. This is axis 2. This is M2. So the lengthwise moment you are getting is 2. Widthwise you are getting is 1. Correct? What is wrong? Someone commented there, M1 20, M2 30. No. Lengthwise not M1. Lengthwise is M2. See, the lengthwise you are getting is M2. Clear or not? Confusion should not be there. This is, see the direction. This is your lengthwise moment you got 20. That is your M2 about this axis. Why? There's a doubt there. Clear? I think. See, no comment. At least it will clear. M1 20, M2 30. Then again, some comment came, M1 20, M2 30. Such confusion is dangerous. See, here, small moment, no problem. If high moments are there, see, for one of them, 1.95 into 9.2 square. Other is 9.2 into 1.995 square. It will be very, very dangerous. See, for one of the moment, it is 1.95 into 9.2 square. Other one, 9.2 into 1.95. See, I will tell you one thing. A moment applied this way will have a denominator of, see, if you apply moment this way, it has denominator of what? 9.2 into 1.95 square. A moment applied this way, see, this way moment applied, it has denominator is what? 1.95 into 9.2 square. So, severe error will come. If you don't consider that way, severe error will come. So, it is very important to observe how you took. Actually, M1, M2 names are not required. You put the moment there, you don't write L1, L2, don't even write 1, 1, 2, 2. See, for this moment, this is the depth, this is width. For this moment, this is the depth, this is width. Or for this moment, 9.2 to be squared. For this moment, 1.95 to be squared. If you understand that one, M1, M2, 1, 1, 2, 2, that all not required. Clear now? That's all not required. See, when I calculate, I never bother that M1, M2. I see the moment there, accordingly put the pressure. Okay. Now, this is safe. Now, also, so safe in what? SBC point of view, safe. So maximum gross pressure does not exceed SBC. It is much lesser. See, it is only around 80%. This is only around 80% of SBC. Correct? So 20% margin is there. Tell me now. 20% margin is there. Shall I revise this one? One thing guaranteed, I am not calculating. PG minimum is infinite percent guarantee that it is positive. So don't have to worry. Why? This one, see, it is plus, minus. When you have 150 rupees, this 5 rupee, 1 rupee, if you spend, still money is with you only. So you don't have to worry about PG minimum now. Okay, start now. Now, what you feel? Around 20% pressure is lesser than SBC. One of the option, people will tell, I do not want to waste, so I will reduce the footing size. You can reduce, say, you can try. It of 9.2, you can make a try with around 8 point something, and 1.95, say 1.75. You can try if you want. Okay. But so that maximum pressure will reach almost 200. Yes, if any problem is there or space problem is there, suppose you want some other space there for some other footing, you can try. But if the space is available, this half meter or I don't know how much, around half meter and around what? Some few centimeters, some inches. If extra given, any problem, it will give more stability. Therefore, tell me, shall we revise or proceed further? Safe with good stability now. It is a very good stable, and fortunately we got what? Resultant column load almost through CG of the footing. And second one, pressure also 20%. If you have 100 rupees in the pocket, bill came 80 rupees. Good. So 20 rupees, we can increase by taking. No. Then you have to once again change everything now. I can do it. We can increase by taking 20. Okay, that means we have to revise. Now, shall we do it or not? You know it now. See, important is you should know. Here, shall we change it or proceed further? This has been done so many times earlier. Revisions all many times done. So, what will do? Shall we change or proceed further? 25% no. Now you have to go for trial and error. We will proceed further. Why? Early. Suppose you know that 80 rupees you have to pay. If you have 100 rupees, you don't come back to home and keep 20 rupees here. Let it be there with you. Okay. Now, say power. See. Further. Next step. You make a note. Very important. Make a note. It always happens. Make a note. Footing dimension of width 1.95 meter, length 9.2 meter, and the projections we considered, everything is perfect. So good margin of safety. So now pressure point is over. Now go to your structural part. Structural means RCC part. See here, we never bothered M20 concrete, M25 concrete, tar steel, R steel, E steel, nothing. Now go to RCC. I told repeatedly for you, when you enter the structural part, RCC part, we do not require PG. We require what? Tell me. You do not require PG. We require what? We do not require PG. We require. What do you require? We don't require PG. We require net pressure. See, when you want PG, your interest is only two values. One of them is maximum, other is minimum. Actually, I will tell you, the maximum pressure will be at the corner 3. At corner 3. Minimum pressure will be at corner 1. This is the corner where pressure is least. This is the corner where gross pressure is maximum. But you don't require where. But now you need what? You are going structural part. Therefore, I will remove this one now. See, therefore, right here. Now you are going for what? Now, calculation of net pressure. Net pressure. Write the reason here. What all I tell right now if you want. Now, our footing dimension is checked. Footing dimension in plan we check based on gross pressure, including self-weight of footing. But when you go next step for RCC part, bending moment, shear force, etc. for the footing slab, at that time you have to consider net pressure. 1.1 is not to be considered. Tell what to be considered? No 1.1, only P by A. So net pressure at any corner, Pn equal to plus P by A plus or minus M1 by Z1 plus or minus what? M2 by Z2 plus or minus M1 by Z1. Oh, M1 by Z1 plus or minus M2 by Z2. Okay, now only P by A. So equal to, I'll tell you now, equal to, see, 2500 divided by this much plus or minus. Okay, I'll do one thing. Or I'll write once again here. It's some other way. Or you can write, this is same, plus or minus. Some will tell, sir, earlier you had done some other way. I am doing it this way. You do whatever way you want. Now, this number is only 10% lesser. That's all. 2500 divided by 9.2 divided by 1.95 is 139.353 kilonewton per meter square. Now, this is always plus. Now remember, start. Net pressure at corner 1. Corner 1. Not, now your axis not required. Net pressure at corner 1. Net pressure at corner 2. Now you require all the pressures. Corner 3, net pressure at corner 4. Rounding off I am not doing. Corner 3, corner 4 equal to plus, see, corner 1. Or do one thing. You decide sign and tell me the answer. All values are in kilonewton per meter square. You decide the sign. See, for corner 1, M1 is this way, M2 this way. You decide. See, at least some contribution from you. You decide and get the 4 corner pressure. I will not take a break. I will just be outside only because little problem. What happened is, nothing happened. I went outside, got cut by mosquitoes here. Now, that is the problem. So, slightly, there is a remedy for that one. This mosquito problem in our area, when rainy season or rain comes, it is severe. Okay. Now do one thing, don't waste time now. You get the 4 values, type the 4 values in order. Where plus, where minus, you should decide. Why? How many times I have to keep on telling where plus, where minus? It is your problem now. Start. I will come in around 5 minutes. Within 5 minutes, get the 4 corner pressures. 1 plus 133.48 sufficient, second decimal. Second one plus 134.94. Next one plus 145.23. Further one plus 143.77. Okay. For your information, see, actually I need not tell. First of all, I should stop this repetition. But what to do? There may be people who are newcomers. Little information for them. See, M1 is like this. So 1 and 2 negative. See, all positive. Due to M1 is like this. 1 and 2 negative. Whereas 3 and 4 positive. M2 is like this. 1 and 4 negative. And 2 and 3 positive. Now, pause, tell me. Suppose after half an hour you tell values are interchanged, wrong means serious problem will come. See, what happens is sometimes only one person will give the answer. After some time, by mistake, some interchanged. I will stop the class at that time. See, then, see, only one person giving answer, others are keeping quiet. Means, by chance later, this is wrong. I will stop the class at that time only. Because I wrote steps also here. I don't want to check this one. Only one person. I will check later. Remember, for others, in case later you tell, no, these are interchanged, I cannot do anything. Because this is YouTube class. See, again, same, it happened earlier. After some time people tell, sir, this is something. I will not accept it. I got doubt about this value. See, 1 minute. I will see right now. See, because there is no involvement of other for arriving this answer after telling so much, then if it is wrong, I will stop the class now. That's all. See, I will check because this is a YouTube class. It is permanent. I do not want tomorrow someone to put comment. Values are wrong. Okay. Because I got some doubt. 1. 133.48. 2. 134.94. Okay, next. I got slight doubt. 145.23. Last one. 143.77. Okay, done. Okay, now be careful. Your design principle will change. These are the pressure. Now what you do is, see, let the 4 corner pressures are here. I will not write anything. I will go for now design principle. When I go to design principle, these values are required for me. Okay, I will not rub everything. This side remove. Because when you go for design, systematically go for design. Okay, now it counts whether it is beam type or beam and slab type right here. Now it matters. That is whether only slab type or beam or slab type, beam and slab type. I already told you, rigorous design I am doing for this one. That is at present practically almost outdated. Still, after this question is complete, briefly I will tell that one. But in the ETAB software, I will prepare the model with what? Beam and slab type. Analysis all ETAB will do. Result I will explain at that time. So I will go for the most popular. So now write. Now write here. We will be designing we will be further designing, we will continue the design with only slab type. Okay, now these 4 values are required. 1 minute, I will see the comments. If it is there in the correct order, I can rub everything. 133.48, 134.94, 145.23, 143. Okay, correct. Okay, I can rub now because why? I can see. I don't have to ask you. Okay, now start. Nothing required now. All gone. See, today evening or by tomorrow morning, for those who are in the ETAB batch, I am sending some information regarding this design solve. You have to answer it and give me. You have to tell 2 options, either yes or no, that's all. You have to give 2 options. I will continue based on majority. I will tell you what is that one. It is a personal matter between me and only ETAB batch. So I will in a letter, I will write everything in 1 page and send to you today or by tomorrow morning. You go through it and reply, put the comment in the group. You comment back, tell yes or no. Depending on that yes or no, I will go further. So I will make the final decision based on majority. I know that, to be frank with you, majority decision will be yes only. I know it. Maybe only maximum 5 or maximum worst 20% may tell no. 80% people, I am sure, 80% people will surely comment yes. But your option. Just because you should not do that way. He told majority will tell yes. If I tell no means he will know my name. Don't feel bad. I will write there. You are free to express your views. What? Only between me and ETAB batch. Okay, start. Now, only slab type, I will put a sketch here. See. Now, this is the footing. See, I am writing here for some reason. I am writing here for some reason here. Little small I will write because my space problem. Okay. This is the footing slab. See. Remember now, all little more thickness. All these are important for design part. See. This is the footing slab. Okay, now, okay, little this side, 3-dimensional view. Now, not to the scale. This is your 1.95 meter. The total length is, you know it, 9.2 meter. There is one column here, lengthwise more, widthwise lesser, this way. Okay, sir. There is another column here, out of scale. Scale is not maintained. Scale is not maintained this way. Okay. Now, there is a load here of 1100 kilonewton. There is a load here of 1400 kilonewton. And there is a moment this way clockwise. There is a moment here anti-clockwise. That is lengthwise. Also, some widthwise moment is there, not required for me. You see only lengthwise. See only lengthwise right here. See, we are consider lengthwise bending. Consider lengthwise bending. That is this way bending. Do not see that one bending. Okay, now below pressure will come. Now, how it will bend? See, if you see from front view, see, you can see like this slab. Now, one point load here through the center of the column. See, where column is there, through its center. One more point load here, where column is there and center. One couple here, one couple here. And pressure variation will be, I don't know, it can be like this or it can be like this. Anything is possible. But today, or rarest of rare case, it can be uniform. Okay, I will take one of them. Now, I will call, now see, now this bending, tell me how it will bend. 100% this will sag. 100% this also will sag. This middle portion depends on the overhang. It may sag or it may hog. So, see, two chances I write here. Two chances. This is chance 1. Chance 1. This will hog. Chance 2. This will sag. This also will sag. Even this also will sag. That is, if it is chance 1, see, you require bottom steel here. You require bottom steel here and top steel here. This is for your chance 1. And if it is chance 2, you need only bottom steel. Tell me, why sagging bottom steel, sagging bottom steel, hogging top steel. Here, sagging, this also sagging. This I told you earlier, only bottom steel. This fully clear? Fast. These all you make a note and write fair copy. Fully clear? Fast. There is little work for you now. Full clear or not? Those who are serious, again, I am asking question for those who are serious. I won't see the people watching there. Maybe some are watching for time pass. Not all. Okay, clear. Now, but if you see the sketch there, do you think this bending will come for entire width? Tell me. Do you think this bending will come for entire width or only for some width covering the columns? This way, tell me. Do you think this bending, lengthwise bending will come for entire width or only for some width to either side of the column? Fast. These all you have to write a note, because later I am not writing in the board. I will write in the board statements. What all I am dictating, you should write. Tell me. Is this bending full width-wise, complete width, will it bend this, will it bend, see, this way, or from column up to some distance, at the edges, it may not bend that way. What answer? What? Full width is involved or partial width in the center, central sum width, That is the problem. Only central sum width is involved. This is for slab type. If it is beam type, complete different. If it is beam type, this bending is for what? Tell me. If it is a beam type, then this bending is for what? Not for slab. If it is a beam and slab type, what I explained now is for which one? If it is a beam and slab, what principle I told now, bending, it is only for which one? It is only for, no, I told this bending lengthwise, I told slab type means up to some width here. Edges, no, that will not bend that way. That is, this is for only slab type. If it is a slab and beam type, no, then slab will not bend like this. I told you yesterday, slab will not bend like that. See here, this is the slab, this is the beam. Slab will bend lateral. See, which will bend lengthwise? Then which will bend lengthwise? Slab will bend lateral, complete length. No. Complete, not that way, widthwise. This bending, what I told, if it is a slab and beam type, then The lengthwise bending is only for which one? Lengthwise bending is only for beam will bend lengthwise. How slab will bend? Slab will bend like, see, there's a heavy beam here. See now, I cannot show it here. I had shown yesterday sketch only for you. See. Ayo, this. Okay. No, when I go to beam and slab type, at that time I'll explain. See here. This is the slab. Now, see, today no beam. When there is no beam, see what happens now. See, pressure all. See here, pressure all will clear now. Due to column load and pressure all, see the bending here. See here, bending. Clear or not? Column load is my fingers. See, pressure is from below. See, sagging, hogging, sagging, you can see. This way. Tell me, clear or not? Fast. Lengthwise bending is considered for the slab. Fast, tell me, clear or not? This lengthwise bending I am discussing for only slab type. See, you are not answering, clear or not? Clear. If it is a beam type, see, this is the beam. Then how slab will bend? See here now, due to pressure. Tell me, how slab will bend? Lengthwise or widthwise? How slab will bend? Lengthwise or widthwise? How, if it is a beam and slab type, how slab will bend? It won't bend lengthwise. It will bend what? Bend widthwise as a cantilever fixed at the face of the beam. That is your theory next, second chance. Or that is second type, beam and slab type. So, now, there is a problem. See, if you consider some width, doubt comes. Up to what width? See, up to what width? See now, you should write everything now. What all I am telling. This lengthwise bending will take place only for some width here. Okay, now, up to what width? Up to what width? Not very small. See, maybe this is 1.95 meter. This full is 1.95 meter. Maybe, I don't tell 1 meter strip, maybe for 1.2 meter or 1.3 meter like that. Remaining here, it can't bend that way. Why? Where is support there? Okay, now, problem comes. Theoretically, you cannot decide up to what width this bending is there. So, what we will do is, we will not consider this way. See, we will consider entire, this slab will bend like this for entire width of 1.95 meter. Clear now? We will consider bending, this type of bending for entire width of 1.95 meter. Entire width of 1.95 meter. Clear or not? First, entire width of 1.95 meter. First, tell me, clear or not? This, when you consider this bending, the width, for what width of the slab will bend lengthwise, we will take full width of 1.95. Okay. Now, what widthwise? Suddenly widthwise came. What is that widthwise? What is that widthwise? We will consider what? See, I will tell you. You write here. He took a book, used some, see, applied some load pressure. See, here I am not applying pressure here. I will take this bending for the entire width. Full slab will bend like this. See, column load, pressure. See, this full will bend. But actually, at the edge ends, it will not bend. Okay, now, therefore, what we will do is, we will consider this as a beam. This slab, we will consider as a beam of width equal to, first, this slab will be considered, I am not writing on the board. What all I am telling, those who are serious, write everything. This slab will be considered as a beam. Considered as a beam. Beam bending lengthwise Actually, beam is wide beam. It is a wide beam. Bending lengthwise, subjected to two downward point loads, that is 1100 and 1400, along with the two couples. Which one? I don't know. Tell me what is couple. I forgot. Tell me what is lengthwise couple. What is that lengthwise couple? I forgot it. What is that lengthwise couple? That lengthwise couple, how much? This lengthwise couple. See, not giving answer. Otherwise, I had to go to last class and see it then. That lengthwise couple. If you don't give the answer, 100 kilonewton meter. This is 140. Don't interchange now. Are you sure? Don't by chance tell tomorrow that this is 140. Left side 100, right side 140. Okay. You see, suppose you give a wrong value, it will give full nonsense answer later. Okay. This way, two couples, one this way of 100, one this way of 140, together with upward pressure, together with upward pressure. Okay, now together with what? Together with upward pressure. Now upward pressure is in the form of trapezoidal variation. Upward pressure. Okay, now but actually what bending you are getting, bending moment, shear force you are getting, is considering entire width bending. Tell me, the bending will be more severe where? See, this will be based on almost average value. You are taking full width, but actually what result you get SF and BM, it will be more severe if you take a strip where actually that SF and BM you are getting will be more severe if you take a strip directly where? If you take a strip this way directly under what? Covering. The bending will be more severe if you take a strip directly under the column. Whereas if you take a strip outside, away from the column, actually bending and shear will be more or lesser. If you take a strip outside, see, I will put the plan here now. See, there are a lot of, but actually nothing to worry. See, now see, this is the plan. If I take a strip directly under the column, see, column is here. This strip will have severe bending. Severe. Whereas, if I take a strip here, bending will be, bending and shear, this is severe. Bending will be less or more. Tell me, if I take a strip away, either there or if I take a strip here, bending will be more or lesser. Bending and shear, it will be lesser. Now what you are doing is, we are not taking strip, we will consider what? We are considering entire width. Therefore, what SF and BM we are getting will be based on average. So, for safer side later, what you can do? See, nobody will, suppose somebody argues with me, I will counter argue, no doubt, don't worry. I will counter argue. You don't argue. Therefore, if you take the full width, somewhat average value comes. Imagine when you take full width, your maximum shear force comes to say 100. Maximum BM comes or 100, say 400 kilonewton. Bending when comes to 250 kilonewton meter. Just imagine, right here, if you take the full width and consider what? Entire slab will bend as a single unit, which is not correct. which is not correct, then you should write that way. Suppose I take entire width, then imagine your shear force somewhere maximum comes to 400 kilonewton. Bending moment comes to 250 kilonewton meter. Then, fast write, you write comment. Then, if you by chance take a strip directly below the column here, tell the answer. The SF and BM, will it be more than this value? This is average basis. That is average basis. The SF and BM, if you take a strip under the column, will be more or lesser. If you take a strip under the column, will be more or lesser. First, if you take a strip, this is the average value. Lesser, this much, after this much explanation, it is severe, it will be more. Whereas, if I take a strip, see, this column is here, somewhere here if I take a strip, then this is this SF and BM will be what? SF will be more than 400, BM more than 250. Here, your SF will be lesser or more? Less than 400, less than 250. Clear this concept? This all you have to remember. This class is meant for software. Later, manually nobody is designing. Therefore, the purpose is to understand. Someone will tell, sir, such a lengthy. Why you bother? You understand the principles. That's all. Later you are not doing. Software is doing it. You are not doing it. Tell me first. Clear or not? Principle clear or not? First. Clear. Okay. Therefore, what we will do is, if you get 400 and 250, see, if by chance this BM is not 250, 300, it is 500, this is 500, this is 300, then designing for that is danger. So what we will do is, we will consider the entire width and calculate SF and BM. But when you go for design, we will consider a strip near the column, under the column. Surely effect is more severe. Yes or no? This is on average basis. We will take a strip directly under the column. Either side half of meter. 1 meter strip we will take. Then surely effect is little severe. Tell yes or no? Effect is little severe. Tell me yes or no? Effect will be severe. You tell yes or no? Effect will be severe. No answer. I just want yes or no. It will have act severe. Therefore, how much severe we are not knowing. So what we will do is, some percentage SFBM I will increase. How much percentage I will increase based on my judgment? I will increase by around 25%. I feel okay. Anyway, factor of safety is there, so many things are there. Little liberally you will decide. So if you take 25% more, if the design is liberal, automatically it will go safer side, that finally you will be designing for around 30-40% more. Okay. 25% more. But outside actually you can reduce. Outside you are not designing. So therefore, at the time of design, we will take a 1 meter strip, and result we will increase by around how much? Around 25%. Somebody may ask me, how you know 25%? I don't know. It is not possible. Why? Complicated behavior. See, this bending is complicated behavior. Actually, this footing slab will also bend widthwise. Why? Under the column. See, under the column, for some width here, it will bend widthwise also. All mix-up is there. So, not possible. Only possible is you analyze by finite element theory, where this footing slab you have to break into parts, then strain compatibility or displacement compatibility, FPM will consider and it will give correct answer. Remember, your SAFE, SAFE, slab analysis by finite element method. Therefore, in the SAFE, it will give correct answer. So, therefore, since you are designing by SAFE, it will account it. And one more thing I will tell you now. See, one more thing. When you go to SAFE, what we will do is, see, suppose I will put here. I will put somewhere here. Make a note. When you go to SAFE, randomly I will show one of them. See, this way. Column is here. Okay. Okay, I will put plan only. Plan will do. Sufficient. Plan. You see, later in the SAFE I will explain. Column is here. Column is here. See, quite good width is there. I will take a strip here. It will give BMD, for example. See. This way it will give BMD. Now, if I take a strip here, SAFE will give BMD like this. If I take a strip somewhere here, SAFE will give BMD. And if I take a strip here, SAFE will give SFD, see, randomly. Not linear, parabola is there, it will give SFD like this. Okay. If you take a strip somewhere here, outside, SAFE will give SFD this way. If you take a strip somewhere here, outside, SAFE will give SFD this way. And if you design by SAFE, if you take a strip here, SAFE will tell you steel requirement, see, 2000, it will tell you 2000 here, 1900 here, and top steel required of 2600 mm square. If you take a strip here, SAFE will tell requirement is 1400, 1600, 1900. If you take a strip here, SAFE will tell requirement is 900 here, only 600 here, and 1000 here. If you take a strip very near to edge, SAFE may tell you requirement 450 here, 300 here, and 600 here. You provide this one, safe or unsafe? Tell me. So this variation all actually by finite element method, where this footing is broken. It will ask in the SAFE one word called meshing. Meshing. When you do slab design in the software, I will explain now only. Later I will not tell you. I will not tell. A term called meshing comes. Meshing means you break the slab into parts. Piece, 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 piece. This way meshing. Tell me. If the mesh size is lesser and lesser, accuracy is fast. If, see, somebody may do meshing like this. This way, tell me. As the meshes, this meshing is closer and closer, accuracy will be fast. If the meshing is closer and closer, accuracy will be fast. Accuracy more. Actually, usually we give mesh size of around 0.1 meter. Okay, sufficient. Then SAFE will take at least some 20 seconds to analyze. I once tried in the SAFE, I give a mesh size of 0.1 millimeter. Can you imagine? 0.1 millimeter. I tried in the class deliberately. Means what? Then number of elements are, see, 0.1 millimeter I took, meshing. I will show you there, see. This way. Then, tell me, number of elements are high or less? I will show you in the ETABS class. I will take 0.1 mm mesh size. Number of elements are more or lesser? Very high. So, time required will become more or lesser. Time required will come, more or lesser. Time required by software, more. It took nearly, I don't remember now, say half an hour it took. Half an hour, it was in hanging state. It was telling chakra. It was only telling processing. Once I tried 0.001 millimeter. You do not know. Next day morning also, it was only telling analyzing. Then I switched off. It told this is beyond the limit. See, there is a limit. It is beyond the limit. It is what? It is beyond the limit. So even SAFE failed. It actually, after some time, if I waited, finally it was given error. The mesh size you have given is beyond my capacity. Something like that will come. Next day morning also, that chakra was turning. You know what is chakra? Bye-bye, you get it. Net problem. It is not net problem. It will tell processing. Never ending. So I will tell later, around 0.1 meter is comfortable. So these fluctuations, see, these fluctuations of SFBM more severe under the column, strip under the column, less severe outside. When you do manual design, you should take care. You should give some margin, percentage. Say, how much I told? Around 25% liberally I will give you. Okay. But when you design by software, you need not bother. First of all, when you design by software, you need not bother about anything. You design. It will design the principle. It will show you lengthwise this much steel required, widthwise this much steel required, what is the shear post lengthwise and shear reinforcement if you design, what is the stirrups required, it will tell. You don't require any knowledge. Now imagine a person without structural knowledge, if you do practical design, what he will be knowing first of all? He will see the display there, provide steel. In so many design offices, senior will tell the junior, see, you do this way, see the numbers here, accordingly decide steel. Junior will tell, okay. Then after some time, the junior will continue that work, maybe for 1 year. Then he will tell, I am structural expert. He will tell, I am structural expert. How? I will ask him, what way this is designed? I don't know. Then you told structural expert. No, I am expert in result. That is clerical job. I am not degrading clerks actually. No, don't think that way. By telling clerical job, I am not insulting or degrading clerical job. Clerical job means what? Simply write and do it. See, write. See there and write. So don't have to think too much. Their important is values. So therefore, without structural knowledge, if you go to design field, one fine day, someday or other, you may have to pay heavy penalty. Why heavy penalty? Some drastic problem. See, if you got good structural knowledge, by looking at the result, you can make out. Either you can tell okay, or you can tell, see, there's something wrong here. See, by looking at the result, you will tell something is wrong. This is not possible. That feeling will come only for those who got reasonably good structural knowledge. So, all this you understand, then only your software, your design grip software will be complete. Do not think that way. Software class, he is telling structural basic, not required. What not required? That only I am asking in the group. See, I will tell them all these principles, little more are there about combined putting, beam type and the drop type. If you do not want, tell me, no problem for me. I will start immediately software. Later, if you ask, sir, that is not clear, then why you told software only required? So, therefore, I will write letter for them only. See, all this clear now? Fast. Now remember, you should be very, very careful. See, start. Write. Of all the statement you write, then write. First, consider longitudinal bending. longitudinal bending for slab. Okay. Consider entire width. Consider entire width of what? Or footing slab. See, longitudinal bending of slab, that is for length of answer. Consider longitudinal bending of the slab, that is for length of answer. That is for length of answer. Length of 1.95. How this idea comes? Comes here, longitudinal bending of slab, that is bending for a length of. That is bending for a length of 9.2 meter. And remember, consider full width. Full width of what? Full width of how much? Tell me. Full width of how much? Consider full width of how much width? Consider full width of how much width? Full width of 1.95 meter. 95 meter. Now, consider as a beam for SFD and BMD. Consider as a beam for SFD and BMD. Okay. Now one very downward loads are in kilonewton. You write here. Downward loads are in kilonewton. Couples are in kilonewton meter. See, finer points. These all cannot come by hearting. How I know this one? Don't tell I by hearted. I never bothered. If the question comes like this, if somebody makes a mistake, I will tell wrong. That is not matching with the correct design principle or mathematical part. Downward loads are kilonewton. So when you take moment, kilonewton into meter will come. Okay, then your upward load is pressure. Upward pressure is, tell me answer. Your upward pressure, randomly I will put here. See, randomly I will put here. Upward pressure is in kilonewton per what? Upward pressure is in kilonewton per. Fast. Kilonewton per. Upward pressure is in kilonewton per meter square. Meter square. Okay, 1 meter. You can take kilonewton. See, what I am telling now, I will tell only once. Only once. Because this is not an academic question. If it is an academic question, I will tell 10 times. I will tell them by heart it. You repeatedly go through and write. Upward pressure in kilonewton per meter square will become kilonewton per meter only. See, this kilonewton per meter square will be kilonewton per meter only and only if width is how much? Tell me. Only and only width or B equal to how much? Tell me. This is told 1000 times. Upward pressure in kilonewton per meter square will be kilonewton per meter only and only if the width is how much? If the width is 1 meter. Width is 1 meter. But here width is not 1 meter. Width is not 1 meter. Actually here, tell me, width equal to how much? Actually here, width equal to how much? Tell me, what is the width here? What is the width here? First, it is not 1 meter. Width is 1.95 meter. 95 meter. Therefore, what do you have to do? For that kilonewton per meter square to be what? To be changed to kilonewton per meter, multiply the pressure by how much? Tell me. I want kilonewton per meter square to be kilonewton per meter for the full width. Multiply the pressure by. Answer. Kilonewton per meter square is for 1 meter strip. But width, common sense will do. If the width is 1 meter, it is kilonewton per meter. Okay. Kilonewton upward load is in kilonewton for 1 meter length, 1 meter width. Length you leave it. So it is kilonewton per meter if width is 1 meter. But width is 1.95. I don't know. This is last answer. Okay. Multiply it by 1.95 meter. 1.95 meter. If you do not do this step, you are making a blunder in the structural part. Tell me, fully clear or not? You go through the recording 10 times and understand and write. Later you don't require. Why? ETAB will consider it. See, ETABS&SAFE will consider all this programmed. It's all programmed there. You need not bother. Clear. Now, which pressure? See, 1 minute. You know pressure, I want lengthwise bending. Now do one thing. I will write one more thing here. See, to save time, write the net pressure. Net pressure. 1, 2, 3, 4. Okay, now start. I want upward load here. See, upward load. I don't know how much upward load. See, randomly I will take. I don't know which. 1 minute. I will put the values here. Okay, I will put here. Net pressure at 1 equal to. Net pressure at 2 equal to. Net pressure at 3 equal to. Net pressure at 4 equal to. To be frank with you, see, this design I am making after nearly before COVID. I had done ETABS&SAFE batch. That was in 2018, I think. 18 or 17. Okay, then or 18 I think. 19 not done. 18. 19 I was about to start. Then COVID problem came later. So at that time, last time I did. Nearly 3 years. You know how much I forget. See, 20, 30 I forgot. If I am that much forgetting in nature, how I remember all this one? These all not to be remembered. It is called inbuilt. When you look there, when you take full bending, natural feeling will come. So, okay. Now, these values are, okay, I will go back to comment box and write here. Okay, 133.48 kilonewton per meter square. This is 2. 34.94 kilonewton per meter square. This is PN3. 145.23 kilonewton per meter square. This is 143.77 kilonewton per meter square. Now, see, when I want lengthwise bending, I think if you look at the sketch, tell me, more value will come that side or this side. It is almost UDL. Tell me answer. See here, 133 and 143. Or do one thing, find the pressure here, find the pressure here. This will give average pressure. Average here. Width, average widthwise. Widthwise average. Right here, what is widthwise average? Average. Tell the answer. Sum of these two divided by 2 will give average here. Answer. I will not write 133.48 plus 143.77. If I want average here, somebody who has passed high school level, he knows that it is sum of these two divided by 2. Answer. Average. Average. How much? Average. Sum of these two divided by 2 will give the average pressure here. 133.48 plus 143.77 divided by 2. You are wasting lot of time. See, you are wasting lot of time. 138.63, okay, or 138.625, I put 625 kilonewton per meter square, and average here, don't give wrong value, 140.085 kilonewton per meter square. Therefore, now, if I take the full strip here, these are in kN per meter square. The upward load here will be how much? Tell me. I want upward load for entire width, no 1 meter strip, it will be equal to 133. It is 138.625 multiplied by answer. 138.625 multiplied by, that is in kN per meter. See, that is in kN per meter square. I want for a width of 1.95 meter. If I go for 1 meter length here, area covered is 1 into 1.95. So load into how much? Into 1.95. Tell fast answer. Now it will become kilonewton per what? Tell me. Now it will become kilonewton per. See, daily you don't have to, because understanding, that's all. It will become 270.32 kilonewton per what? Per meter. Same way here. How much here? This is 138. 134. So 140. This is little more. 140.085 into 1.95. Answer. Or you can do sum of these two divided by 2 into this width. Length is 1 meter. Answer. 273.17 kilonewton per meter. This is the upward pressure. Oh, it is almost like what? Tell me. Actually, it is almost like 270 here, 270 is there. So it is actually a design office. If he is doing manually, he will tell one thing. Sir, you add these two, divide by 2, take it as what? See, take it as UDL. Then your SFD BMD will come very easy. Why? See, UDL. Yen sir, what is this? Small variation. No. Today it came. If I replace it by UDL, then how you will learn? If later, if it comes to what? If heavy moment is there, it may come 180, that can come 300. Okay, therefore, we will take as it is. I will write the answer here. I will not ask once again. 270.32. Other one is 273.17. Okay, now we will draw. See, I am not writing, I am dictating. You write what I am telling by words here. See, I will start dictating. Now we will consider a beam for length 9.2 meter and width equal to 1.95 meter. A wide beam subjected to 2 downward point load, 2 couples and upward UVL in kilonewton per meter represented by a trapezium, or the diagram will look like this is for, this we are doing for lengthwise bending. Remember, again and again, this you are considering for lengthwise bending. So the beam you require for SFD BMD is beam like this. This is the beam with see one total length 9 meter, correct? 4.5, 2.25. The left projection is, tell me, What is the left projection first? What is the left? I put it. What? Okay, wait. Okay, right here. And then one. Okay, I done one thing. I read the pressure diagram also. Here, upward pressure is 270.32 kilonewton per meter, not meter square. Here it is little more. See, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಆಯ್ತು. ಹೀಗೆ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ, ಅಷ್ಟೊಂದು ಜಾಸ್ತಿ ಇಲ್ಲ, ಬೇಡ. ತುಂಬ ಹತ್ರ ಬೇರೆ ಗೊತ್ತಾಗಲ್ಲ, ಸ್ವಲ್ಪ ಇಳಿಸ್ತೀರಿ, ಸ್ಕೇಲ್ಗಿಲ್ಲ, ಬೇಡ. ಯಾಕೆ ಗೊತ್ತಾಗಬೇಕು. ಅಪ್ವರ್ಡ್ ಆಫ್ ಎಷ್ಟಿದು 273.17 kilonewton per meter. This is the pressure diagram. Upward, now no pressure diagram. This is the upward load. And tell me, what is this length? This I will call point A. Why? I always want loaded point A. Tell me. And then there is a couple here clockwise. And what is the projection here? Tell me. Projection. Now I will write projection here. This projection is 1 point. I forgot that projection first. Yesterday we finalized. Tell me, left projection 1.6 meter, 1.6 meter, and right side projection little more. Okay, little more. There is one more point load here and a couple this way, and that right side projection is little more. How much? Tell me. 2.2 meter, and distance between the two columns is, I remember, 5.4 meter. So total is 54, 64, 74, 76, 76, 92, correct? 9.2 meter, correct? And this load is 1100 kilonewton. This load is 1400 kilonewton. This couple is, ayyo martoitu. Tell me once again now. Ali 100 kilonewton meter. This couple is 140 kilonewton meter. I will tell A, this I will call B, this I will call C, this I will call D. This is the system in equilibrium. First, we will do a check. Okay, I will take a small break now. You first check for equilibrium. Check for equilibrium. Remember, long back in the BSK class and SFD BMD, same beam we have drawn SFD BMD. Yes or no? First tell me. Did we already considered SFD BMD for the same type of problem earlier? Tell yes or no. SFD BMD for same type of problem. Tell yes or no. First, yes or no? Yes. Therefore, at that time, for the ETAB batch and also for the RCC batch, I sent a letter there. Remember, later when we go to combined footing, we have to draw SFD BMD for a beam subjected to 2-point load with the couples and upward load in the form of UVL. I am going to cover it today. Attend the class, go through thoroughly, work out, so that later when that problem comes, I will not explain. That's what I am doing today. If anybody new is there here, for example, they are not interested in analysis part. There are so many newcomers for my YouTube class for column and footing. If you are new, go to playlist. There you can see BSK batch. BSK. In the BSK, see there, SFD BMD. There you can see practical example for combined footing. Consider two cases. Once UVL this way, once UVL this way. Therefore, correctly work out. You long back you agreed. Later, When I go to combined putting, at that time, I will keep quiet. I will directly draw the SFD BMD without explaining one naya paisa. You agreed. So this is the time to do it now. 1 minute. There also I checked for equilibrium. Now remember, there when I gave these values, if remember, these values are given by me on that day. Yes or no? These values were given by me on that day. Tell yes or no. These values are given by me on that day. Tell fast. I told you. See, these two values today I am giving you. You don't bargain. You accept it. Now tell me. Now you know how to get these two values. Tell yes or no. Now you know how to get these two values. Correct? Yes. Someone will ask a question. Sir, this much of calculations are there. How you gave it? That you don't bother. Sometimes, naturally, people will ask me, so many complications, width you have to consider, pressure you have to consider, then all these things required. But you told directly answer on that day. How you know it? How I know, you need not bother. You know correctly. That's all. I always tell, do not ask a question, sir, how you are getting answer so fast? I sometimes get super fast answer. No, because this is actually what? It is a basic of strength of material. Okay, now, first do one thing, you check for equilibrium. Check for equilibrium. How? Tell me. Total downward load should be equal to total upward load. And moment of the downward, this given force system, about any point should be equal to moment of this one. See, so once sigma V should come 0, sigma M should come 0, you take moment about point C. If you take moment about point C 0, with sigma V 0, it is guaranteed that system is in equilibrium. Clear now? First, system is in equilibrium. Okay, now I will give briefly. Sigma V, downward load, 1100, 1400. Upward load, 270.32 plus 273.17 divided by 2 into 9.2. They should match. Take moment about this point. 1100 into 1.6, 140 into this distance plus 100 minus 140 clockwise moment. Find this anti-clockwise moment equal to 270.32 plus 273.17 divided by 2 into 9.2 into bracket 270.32 plus twice of 273.17 divided by 270.32 plus 273.17 into 10.2 divided by 3. That's all. That's all. I never by hearted. I told by seeing there. I told so fast why you should not able to write. Okay, start. I'll take a small break now, maybe around 10 minutes time. By that time, do one thing. Those who are serious, proceed further to draw SFT BMD for this UVL somewhere outside. You have to prepare V-X and M-X. Remember or not? Only for upward UVL you require V-X and M-X. Yes or no? Tell me. Remember, so that for substituting X value, you can find SFBM. Remember or not? V-X, M-X. Fast, tell me. Yes, you can prepare that one in the break. Okay, I will not take 5 minutes, maybe little more. Why? Too much of talking with high voice. It is really straining. So I will take around 8, 9 or 10 minutes break. Now it is 7:02. 7:10, 7:12 I will start. By that time, you write V-X and M-X. 1 minute. I will tell that only and go. 1 minute now. I will start that and go. Equilibrium is guaranteed. I am sure. Equilibrium I am not checking because it is given by me. When given by me, 100% it will satisfy the requirement. Those who are coming to my class, they have that confidence. They will tell. If I don't want to tell my name. If KSN tells it is in equilibrium, it is surely in equilibrium. Okay, now to draw SFT BMD, see, I will start and go so that you can start now. Now, for further, for SFT BMD, you consider the pressure Consider only upward load. Consider only upward load. It is like this. This is C, this is D. This way. See, now this length is known to you. What you do is red color. Eli red. Red bara eli. Red color. Okay, red is there. Don't worry. Consider a section XX at X from here. Then this pressure is known for you. This pressure is known. This is the pressure W in terms of X. Upward load. Get it in terms of X. Then tell only due to upward load, get the answer. Shearing force at XX. Say V dash X equal to, and bend, sag up, left up positive, right down positive, and bending moment at XX. Sagging positive. Tell the answer. This is called M dash X. M dash X. Get these two answer. This will come. One X will come. One X square will come. Here, one X square will come. One X cube will come. You prepare this one and wait for me. Prepare this one and wait for me. Someone will tell, I have not attended earlier. Okay, you take a break. After the class is over, go to BSK class, and this is given there, heading SFD BMD for combined putting, practical requirement. I told her that time, study it, understand, then only what? Start. So today I should see at least some 10-15 views for that class. Let me see. Not that I know what you will do. People will download it and watch it. They won't watch fully online. Why? Data they want to save for other unwanted reason and purpose, like YouTube or Facebook or Instagram, Extragram, etc. Nobody wants to spend data for a class. This I know it. It cannot be repaired. Okay, start. Anyway, agreed now? All those who are serious, tell me, agreed or not? Others are not bothered. Those who are serious, agreed? Yes, okay. Some 3-4 yes is there. That means they are serious. Okay, thank you. Now it is 7:05. It is 7:06 now. I will come at around 7:16. I want 10-minute break. Okay, start. We'll start now. See, first of all, I need not tell anything. Why? Those who are serious, I told, they will understand and solve them that problem. Now, still, just to write something here. See, that is, suppose someone new, he should, if somebody is new, it is their responsibility to go back, what I told, to go back there and study and come back. Okay, I'll tell you, shear force, see, equal to this value, 270.32 plus this value, 273.17 divided by 2 multiplied by x. That is the, sorry, what is this one? See, before that you require this value. I am taking, see, sometimes it happens. Absent mind, it is called absent-mindedness. I want here, I thought I want somewhere here. That value will come, this wx will come 270.32 plus plus 0.3098 times x. That is by interpolation. Is that number correct? Tell fast. Is that number correct? No. Is that number correct? You told equilibrium maintained. Is that number correct? What I wrote, is that number correct or not? I want confirmation. Because if something is wrong, I cannot change it later. That much kilonewton per meter. Tell me, is that number correct? Tell little fast. 0.304. Ayyo. 273.17 minus 270.32 divided by 9.2. No, it is 0.3098 only. 30978 it comes. How you got 0.304? See, again mistake. Such small mistake you should not do. Okay, now your shear force will be, shear force V dash x will be here shear force equal to this value 270.32 plus this value bracket 270.32 plus 0.3098x divided by 2 multiplied by x. Y means, sorry, I cannot explain same thing 100 times. Sometimes people are there, they will tell incomplete. He has not explained. Then I will tell you have not followed what I told you to do it. They may tell, I need not follow you. Then why you came to my class? If you are not following me, why you came to my class first of all? Okay, now shear force, if you simplify, it will become 270.32. It will become 270.32 times x and then 0.1549 plus 0.15, light problem, 1549, 1.49 x square, and bending moment will come. I write here, actually not required, tricks are there. Okay, leave it. There you require boundary conditions all. Leave it now. It will be equal to m dash x will be equal to bending moment here 270.32 plus 270.32 plus 0.3098x divided by 2 into x is the total load multiplied by moment about this point is 270.32 plus 0.3098x, this value plus twice of 270.32 divided by 270.32 plus 0.3098x plus 270.32 into x divided by 3. This will cancel with this number. Simplify it. You will get 135.16x. You will get 135.16x square. 135.16x square plus, correct? 1x square, and then 0.05, little more accuracy, 0.05163 sufficient times x cube. Very systematically, very thoroughly explained in the BSK class. It is in the YouTube. Go through that one. And those who are in the ETABS&SAFE batch, they have to go through. Because why? The class main purpose is for them only and for RCC batch. Others get as much benefit as possible. Okay. Now, I will remove the sketch. Now remember, if I want shear force or bending moment anywhere for pressure, substitute x from here and get the answer. Okay, start. The sketch I will remove, that I will still maintain. Before that one, is it correct or not? First, the two equations, are they correct or wrong? If any wrong is there, I want to clarify. I want now only to know. Did you get it? You know, here fine both means not clear. You need not find both, I think. Second one will come easily. Correct? I know it. Second one will come easily by integrating first one. Or, see, both are fine. Okay, now, start. Remember now I am completing SFD-BMD with the minimum explanation, full explanation given earlier. So, you once again go to that class, study and come back and solve. Start. Shear force calculation. Briefly. Left up, right down, positive. There are still people who, if I ask, left up positive, right down negative. Why? Natural they will tell. Left up is positive, so right down is sir negative. Very good. That's how you should study. That is called lack of knowledge. Okay, start. First, shear force at C, 0. Shear force at A, remember point load is there, just to left of A equal to, substitute x equal to, how much? 1.6 meter. Answer fast. See, here, just to left of A means only this much load. Only that much load means x equal to 1.6. Answer. Second decimal, first decimal is sufficient. Answer. Only first decimal sufficient. Why? Design problem. Tell the answer. Only first decimal. First answer. Or do you want me only to struggle once again? But don't give wrong answer. At least two people should give correct answer. Nodi. No cooperation. No cooperation. Oh, RCB won by 67 runs. Very good. Congratulations. Useless people, they won today. 432.9 plus 432.9 Sakbudi kilonewton. And shear force at A only, just to right, equal to plus 432.9 minus 1100. Anybody can tell this answer? 432.9 minus 1100. Please do not give wrong answer, because YouTube class permanent. Zoom if you give wrong, I can tell you what. You make the adjustment. You take wrong value only. It will be deleted later. But YouTube class, I am not deleting. This will be there permanently. Or if I upload a class later with more clarity and more setting, no like what, half screen here, little visible, all these I may remove. Sometimes professional work. I am trying to make that professional work. If that happens, I will delete them. minus, see, you are not told sign, minus 667.1 kilonewton. Okay. See, only one. At least two people answer. Then shear force at B equal to, you should not use this value. Why? If I use this, sorry, I should not tell. If you use that value, I need this much load. Problem, start from beginning. It is plus your V dash X from here to here load is for X equal to 5.4 plus 1.6 is 6.7 meter. For X equal to 7 meter, then minus 1100. Answer. In that equation, put X equal to 7, then minus 1100. Answer. Fast answer. In that equation, substitute X equal to 1.7 meter, subtract that one, plus 700.8 kilonewton. And shear force at B, just to write, equal to plus 700.8 minus 1400. Some are bound to comment. Everything he explained systematically. Suddenly he is doing fast. I told the reason. See my voice. See how much I am shouting. ನೋಡಿ ತಪ್ಪದು 7 ನೋಡಿ ಈ ಥರ ತಪ್ಪು ಮಾಡಬೇಡಿ. 799.8 ಓಕೆ. ಈಗ ಹೇಳಿ ಆನ್ಸರ್. ನೋಡಿ ಈ ಥರ ತಪ್ಪು ಮಾಡಬಾರ್ದು. ನನಗೆ ಕಷ್ಟ ಆಗುತ್ತೆ. ಇಟ್ ಬಿಕಮ್ ಡಿಫಿಕಲ್ಟ್ ಫಾರ್ ಮೀ ಬಿಕಾಸ್ ಪರ್ಮನೆಂಟ್ ಕ್ಲಾಸ್ ಇದೆ ಯೂಟ್ಯೂಬ್. ಪೀಪಲ್ ಆರ್ ದೇರ್ ಹೂ ವಿತ್ when they cannot find technical mistake, they will comment on calculation mistake. Sometimes spelling mistake also they will comment. So far nobody commented. It is minus, minus 600.2 kilonewton. Okay. Now lastly, at D, you need not calculate shear force at D equal to 0. Or if you are that much eager, it is your V dash X for X equal to 9.2 minus 1100 minus 1400. 0 has to come. Coming or not coming? 0 has to come. 0 is coming. 0 has to come. One small information. 2 days earlier a comment came. A person commented in the class number 100 when I told the concept of shearing force under a point load, ultra special concept. People who tell, see, JTL, JTR. Actually, JTL, JTR is only imagination. It will be slant. I will write the diagram. See, strictly speaking, the actual, if it is linear variation, see, shear force diagram will be it will come this way. But this you take what? This way. That JTL, JTR is imagination. Clear now? Then the comment came there that in the class number 100, you told some ultra special brainstorming questions are there. Where are the questions? As if he is so intelligent to answer it. I know that person. I know that person by some way. I did not comment. Let him wait. I will give it. I will tell him. If second comment comes, you wait. You are telling as if you know. I know that person. Some troublemaker. Okay. He thinks that. Of course, he knows a little. Little is knowing. See, little is knowing. He thinks he knows everything. If he is watching this class, he will understand. I am telling him only. Name I won't tell. 0. Okay. Now, go back and draw SFD. Variation, you decide. Sorry, you decide. Okay. Second degree parabola from C to A to B and B to D. Therefore, I will draw shear force diagram here. I need correct values now. See, here 0. When you come here, it is 432.9 positive. Okay, available space. 432.9 here, or 1 minute now. I want to explain so many things. Therefore, this 1.6 meter, 5.4 meter, 2.2 meter, can I remove it? Tell me. Can you remember? This is 1.6 meter. This is 5.4 meter. This is 2.2 meter. Can you remember it? I want space here for some reason. Or even this also okay, this also I don't require. You write. Because there are some RCC part I want right here. So space required for me down. So here, 432.9. Exactly here. 432.9. Then suddenly changes to 400, 600, 667.1. Then here, just to left, 799, 400, ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಹಂಗೆ ನೋಡಿ, little more, 799.8. Here downside, 600 point. The maintaining scale is important. 600.20 here. Intensity keeps on increasing, so slope will keep on increasing. Here slope is not 0. It has got slope there. Then here also slope is increasing randomly. No, it will come. Okay, later you can make out parabola. This point I'll adjust later again. Okay. This is the shearing post diagram. I told you why curve is like this, why not curve is like this. I told repeatedly, yes or no, why curve is this way, why not curve is this way. Those who are serious, I told them, just tell me yes or no. I explained all this concept. All those who have difficulty for that curve, if they attended my all SFD BMD class, it should be crystal clear. They can go and answer the question anywhere people will ask them. See, that's why when I take a class in BSK or SFBMD, I given too much importance to basic concept. Okay, now draw the shear post diagram. Over. Now, one statement. Shear post diagram is drawn. Shearing post diagram is crossing baseline. How many places? 3 places. 2 of them are known. This is A, this is B, this is C, this is D. A new point I will call E. That you require. You take that point at X from left hand. Why X from left hand? Because if you take X from a nearest point, problem will come. See, suppose by mistake, like if it is UDL, where is the red color pen? Yes, same problem. When I want red color pen, yes. Usually if it is UDL, you take X from here. But if you take X from here, what will happen is, you need this much UVL. So, because you got formula for shear force for X from here. So take X from here. Here. Now, this is the point to be located. See, E point. To locate that one, write shear force at E. You write here. Locating the point E where shear force is 0 between A and B. That is a located point at X from C. Shear force at E equal to upward load plus V dash X for X equal to X only minus 1100 equate to 0, or you get 270.32 times X plus 0.1549 X square. That is the shear force here due to upward load minus 1000. Minus 1100. 100 equate to 0. Interchange here. See, AX square plus BX plus C0. Tell me the value of X. 100% your X has to come more than 1.6 meter and less than 7 meter. Tell that value which will satisfy the range. Other value is non-applicable value. Answer. X value. Solve the quadratic equation, get X value. Earlier I told I will not explain. Someone will comment. He is again explaining. Okay, that is for my knowledge. See, by explaining second time, what happens? What happens is, I also get better grip. Frankly, I will tell, I will get more tiredness. That's all. Only explain 4.059 meter. 4.059 meter or 0.6 meter. 4.06 meter means, see, you got 4.06 meter. We want later what is this distance? Tell the answer. Later we want this distance. From 4.06 subtract 1.6. Answer. See, that is calculated value. This came from equation. Using that value, write the value here. From 4.06 subtract 1.6. 2.46. Now see, this is 5.4. This is 2.46 meter. Okay. From that side, it will become how much from here to here? How much from here to here? From 5.4 subtract it, because this is important for us now. Later when you go for design calculation, that is required. From other side, 2.94 meter. Okay, it is 2.94 meter. No, out of scale. Why? Because I will tell you. See, this is almost straight line. Tell why? Tell me reason. This is almost straight line only. Tell me why almost straight line. Tell me why slight. See, if I exaggerate, you can see like this, but actually it is almost straight line. Tell why? Reason. You cannot see curvature there. First of all, in this SFD, this is also exaggerated. This is almost straight line. All are almost straight line. Tell why? Reason. It is, if you see from little distance, you can't see curvature. Why? Reason. Pressure is almost UDL. Where is, see there? Linear term is 270.32. Parabolic term is 0.15. That will tell you. See here. Linear term is 270. This is straight line 270. Slide. Ayyo. Clear now? But if you get 300 here and 500 here, then curvature is there. Okay. Therefore, this distance will be, ಎಟ್ಟು ನೀವು ಎಷ್ಟು ಹೇಳಿದ್ರಲ್ಲ ಈಗ ಮರ್ತೋಯ್ತು ನೋಡಿ, ಆಯ್ತು ಅಷ್ಟೇ ಕತೆ. 2.94 meter. 2.94 meter. This is little this side. Okay. Out now. Match. This is rounded value. These are obtained by this value. See, when I continue later, this diagram once again required. At that I will take a photo today. Best. Instead of asking you, it is better to take a photo and write it before the class. I will take care of that one. Before I rub, remind me to take a photo, or I will tell one of you to take a screenshot. That is better, because if I take photo in this mobile, it is a problem here. This is only for chat purpose. Sometime even if net is there, this is not working. I have to reboot, then it will work. Very lazy mobile. Only for chatting purpose I use it. Okay, now this I will remove. I will remove this one. Hey, hog manage saku. Now go for bending moment diagram. Lastly, for BMD. BMD, remember, kilonewton meter, and I will tell once again now, BMD on tension side. Sagging positive, remember, right here. We want BMD on tension side. If you are not knowing, learn now. If you want BMD on tension side, even then, first you find BM based on sign convention. Remember, even if you see in RCC or in the software, BMD will come only on tension side. Therefore, even if you want BMD on tension side, what you do? You find the bending moment values with the sign convention only. Then later, seeing the bending nature, what? Plot it. Start. BM at C. BM at C. 0. Don't waste your time. Over. Come to A, BM twice, Y twice, couple is there. Bending moment at A just to left of A equal to somewhere here. Moment of this load, that is nothing but plus m dash x for x equal to 1.6 meter. That's all. Answer. Substitute in the m dash x equation x equal to 1.6. Answer. In the m dash x equation, substitute x equal to 1.6. Don't give wrong value. YouTube class. At least one more person should give the answer. Because sometimes you only will tell. Typing mistake. That's why safer side. If two persons give the answer, I am happy then. Other, nobody is cooperating. If one other answer comes, I get confidence. I don't want to give chance for those people to comment on wrong values. See, this is what happens if all are lazy, if nobody is participating. At least little contribution from your side. So many have left the class now. See why? Reason. Recording. See, recording. The usual habit. Watch recording whenever they want. Here, there also this only will come. Okay, I write the value. Wrong means, remember, I can't do anything. 346.22. 2 suck. And BM at A just to right of A equal to whatever you got. 346.2. See here. Plus 100. Why plus 100? Go to my SFDBMD course or BSK course. See how I explain bending moment under a couple. How to find JTL, JTR. Answer. Start. Why? I can calculate. Plus 446.2 kilonewton meter. Okay. Now that also over. Now come to B. B also bending moment twice. Bending moment twice. Start. Bending moment at B just to left of B equal to somewhere here bending moment. Look this side. It is once again your plus m dash x for x equal to 7 meter and then minus 1100 into 5.4. Lastly plus 100. Tell me correct answer. Tell me correct answer. Charging is on. I think I better remove the charge. No. Today I put the charging on. It is showing full charge now. Now it is showing 88. No, I will not remove. Safer side. It is showing 88 there. Because I decided not to take a chance. Plus 800.54. It is plus 800.50. Color change. Okay, 5 sapidi. And bending moment at B just to right of B equal to plus 800.5. When you come here, see minus 140. Why minus? Your problem. Why? It's already told for you. 660.5. And then bending moment at D, do not waste time, 0. Or put x equal to 9.2 minus 1100 into 7.6 minus 1400 into 2.2 plus 100 minus 140. Hey, calculate, tell the answer. Oh, 0. Right. Now, also we need bending moment at that important point. Which point? At that point E. How to get it? If you want bending moment at E, you look this side. It is plus m dash x for x equal to distance from here. Tell me how much from here you got? 1.6 plus 2. 4.06. What is the x value? For bending moment here, from here x equal to, is it 4.06? Tell fast. Don't use this value. That is side values. From extreme end, is x equal to 4.06? Oh, yes. X equal to 4.06. Then minus 1000 into here minus 1100 into 2.46, lastly plus 100. Answer fast. Kilonewton meter, that BM will come. Minus 374.6. Just to confirm the answer. At least one more person should give that answer. At least one more person should give the answer. But I can check it some other way. I can check that value some other way, because it is almost UDL. The shear force is 667.1 square divided by 2 divided by around 271. That answer, calculator not on. 667.1 square divided by 2 divided by almost 271. Then answer that much minus just to right answer is how much? Just right of B is A is 446.2. 374. Correct. Leave it. Correct. Don't worry. How I checked it. Now right. Now go back and draw BMD. Draw BMD. Okay, start. I will draw BMD here with the colored base. This is the BMD. In all values are in kilonewton meter on tension side, not sagging positive. Tension side. Now, those who are not knowing, do one thing. Right here. If the BM is positive, it means sagging. So tell me, where tension will come? If the BM is positive, it is sagging. Where tension will come? First, top or bottom? Where tension will come? If the BM is plus, it means sagging. Tension comes in the bottom. So therefore, plot below the line. If the BM came negative, it means hogging. Tension comes at the top. So plot it on the upper side. Or you can do one thing, a crude method. If the BMD is required on tension side for a beam, not for column, for a beam, you can do one thing. Plus me, usually in SFD BMD class, I plot positive upper side, negative below. Here plot ulta. Where negative came, plot upper side. Where positive came, plot lower side. That will take care of BMD on tension side. Clear now? All you have to do is reverse. Reverse of how people plot in third semester BE in strength of materials. There, plus means above, minus below. Here ulta. Here see, plus means below. 346.2. 346 point. Little space beda jaga illa. That much space I can't afford. That much space is not there. That much space I can't afford. Okay. Little more. Okay. Once again, same only. Okay. It is 346.2. One of the values. Other is 446.2. See. Here. One of the values is 800. Oh, gone. Why? I should plot below. At jaga beda. Oh, I forgot. I should plot below. Okay, start. One of the value is 346.2, other is 446.2. Okay. Here, one of the value is 800.5, 400 double. Jasti, ee tara. 800 point something, other is 660 point something. Illi. And here, negative came upper side 374. Is it 346? Okay. Now, C joint just to left of a parabola, slope equal to 0 here. Y means no answer. There is a limit for explaining. Then sudden change here. Then here. Illa. Gone. Why? Just to right is 6 not something. Alle tappagodu. reasonably okay. This value is 346.2. This value is 446.2. This value is just to left 800.5. This value is 660.5. This value is 374.6. Now see, this BM is more than that one. If the column comes further apart, your BMD will come this way. This will be very high. If the columns are closer, this will decrease, this will increase. Okay, now 1 minute now. No signs now. See, when you plot BMD on tension side, you should not use sign. Okay, now there is a point here, a point here. This is called point of counterflexion. Using red color, I will mark the point as O1, I will mark the point as O2. I want this distance and this distance, but that is later. So what you do is, last part now. Last part, I will remove. Ayo, I is there. Now see, to locate points of counterflexion, 2 points are there, O1 and O2. What you do is, do not see this one. What you do is, after A, but before B, at X from C, bending moment equal to bending moment plus M dash X for X equal to X only, then minus 1100 into, if this is X, see, don't see there, X from here, X minus 1.6, again plus 100 equate to 0, or it will give you equation what? It will give equation all thoroughly explained earlier, plus 135.16 X square, then plus 0.5163 X cube, then minus 1100 X plus number will come, that number 1110 into 1.6 positive plus 100 is 1876 equate to 0. Cubic equation, you will get 3 values of X, comma, second value of X, comma, one more value of X, but only 2 points are there. So 100% for both the point from here, X should be more than 1.6, less than 7 meter. Tell the two values, both of them should be more than 1.6 and less than 7. Other value will be non-applicable value. Answer. Tell both the values. Tell me both the values, fast. ಇಲ್ಲ ಓಕೆ ಆಯ್ತು, ಬೇಗ ಅದು ಒಂದು ಸ್ಟೇಜ್ ಬಂದ್ಕೊಳ್ಳೆ ಮುಗಿಸ್ತೇನೆ. ಒಂದು ಸ್ಟೇಜ್ ಬಂದ್ಕೊಳ್ಳಿ. ನೋ ನಥಿಂಗ್ ವಿತ್ ಯು. Again, no power today here. Power gone. UPS also getting drained. So they are warning. They are warning me, anytime power will go. Anytime power is not there, government power is not there, UPS also getting drained out. So but anyway, luckily I know it. Up to 8 o'clock it will come. I was sure. Now it came. See, now I will bring to a stage. 1860 no. Ayyo. Adenge 1100 into 1.6 plus 100. Okay. 1860. Okay. Print mistake. Now tell the answer. X value. So again, maybe because of this power problem. Actually, nothing happened so far. Everything covered. I may be forced to close little earlier. Why? Because it is already showing red there. Then very weak, low battery signal is there. They are telling it is showing low battery. But because the two lights are required here. Okay. But not right now. I will take a little more. When it reaches a stage, I will stop. That is unfortunately what to do. See, but anyway, remember, next Saturday I will be in Bangalore. Next Saturday, I will take class from Bangalore where my UPS is fully powerful. It is sufficient for at least 10 hours time. And their power will not go like this. Yesterday evening went, now still it has to come. Here you don't know. Villages always that way. City people get maximum benefit. Village people, they don't get benefit. They are actually supplying food. Annadataru. No. For them, they are useless. Only city, there is no power cuts. Here, sometime 1 day, 2 days, 3 days, no power. People are used to it. Okay, one value is 5.720. 5.720 is one value. One more value is 98. Not possible. Someone told Nandakumar, wrong. Two applicable values has to come. Otherwise, I am permanently closing my class. No teaching, nothing. No teaching from my side. If it is not coming, some calculation mistake, no technical mistake. Mr. Sridhar Murthy is telling 2.39 meter. Other is telling some 5.72 meter positive. One more value he told is minus 26 point. Get out. You are not required. Why should I write it? These are the applicable values. Now, I will check the answer. See now, what I am doing. Don't worry. See, start. Therefore, these both are from C. From C, this way X. I want, see, that is one value from here to here is 2.39 meter. Other value from here to here is 5.72 meter. Now we do not want this way. We want this value. Tell the answer. This is 2.39. Subtract 1.6. Tell me this answer. Bega. We want from nearest standard point. That answer. I can check it now. 1 minute. I will check it now some other way. 0.79 meter. Tell why it required. This will tell you up to what distance the bottom bar from A should continue. Then suddenly from sagging, BM will change over to hogging. Okay, start. Second value is 5.72. This is 7. What is this value? See, remember, this value you write seeing this value. Later, I am removing these values. These are not required. One more value. From 7, subtract how much? 5.72. 1.28 meter. 1.28 meter. Okay. Right. Now, hey, please both of you go. You are not required. Complete BMD is over. Now do one thing. You light line project this one. See. Anyway, remember, if these values are wrong, if you tell me, I will correct it. That's all. Suppose this is not wrong. You tell the correct value, then subtract 1.6 and tell the revised value here. And if this is wrong, get the second X value, then from 7.7 meter, subtract and tell. Check, I will apply at the end of the class. Okay, because approaching 8, I told them up to 8 they told no problem. Okay, now, very, very important. Will not tell once again now. Will not tell once again now. See. Now, complete coverage of the combined putting. See now. From here to here, it is going to sag. PMD on tension side, values are plotted below means it is going to sag. See, this portion is sagging. I am not writing elastic curve. There are sometimes people, when I write this will sag, this is hog, they will tell, sir, elastic curve wrong. I told only for part of that one, keep quiet. Do you want me to draw elastic curve? Can you digest everything I tell about elastic curve? I will tell them. Can you digest if I keep talking about elastic curve? See, this is the reply I will give. Elastic curve, you are talking about me. Do you think I don't know elastic curve? That EID square by dx square equal to mx, that curvature all, that those things all. How much deep I can talk. I am exaggerating. When you write this one, don't see that one. I am not maintaining continuity. So this will also sag. This will hog. Here, tension down, tension up, tension down. Tell me. Now, most important conclusion for today. Most important conclusion for today is there's a column here, there's a column here. See, this point is O1 point, this is your O2 point, O1, O2. This point is C, this point is D, this point is A, this point is B. Now see, from here to here, you need bottom steel. This is your AST for a bending moment of, remember, working load BM. Clear or not? What you should not forget, these are all working load values. Do not make the same criminal mistake. Tell what you have to do. At the time of designing, what you have to do. Be careful. At the time of design, don't forget. Sometimes what happens is, too much of discussion, people forget. What you should not forget. Later, at the time of design, what you should not forget. Factoring actually. You made this mistake many times. Hope this time, deliberately, I will act as if I forgot. I will consider this M value. You should fire back at me and tell, sir, what happened to you? This is nonsense. Multiply by 1.5. I will tell, thank you. But deliberately only. Okay, tell me. This is AST. See now, this is the bending moment diagram. Tell me, you cannot give more steel here, less steel here. What people will do is, this range, they will provide bottom steel once for all. Why? Because even if your requirement is here, extension required, development length. So people will not bother. This region, they will provide bottom steel for bending moment of how much? Tell me. At present, for bending moment of, tell one value. Working load bending moment of. At present, factoring later. Technical understood. This should be able to resist for the full width bending moment of. See the answer. See BMD and tell me for what BM 446.2 kilonewton meter. Someone told sagging. No, I put bottom steel. And here also, tension in the bottom. I should provide bottom steel here. This is AST for a bending moment of, for complete width. Later you are changing to per meter strip. That we will do. Then this will change. But time being, for bending moment of how much? 800.5. Someone will tell 600. No. What steel you provide, it should extend on either side. So I cannot design for 606. And between O1, see, later this steel will be little further extended. Then between O1, O2, you need top steel. This is your AST for M equal to, how much tell me? AST for M equal to. Later in the ETAB, when you move the cursor, I will tell you how it will give you. For M equal to. This is top steel. AST for M equal to. Last answer you are asking. Further, I will not ask too much. Because why? I have to once again explain. See, once again, same problem. Last moment you are not giving answer. 374.6. Someone will tell, what sir, you cannot see. It is there. I can see. I want answer from your side for two reasons. One, to ensure that your involvement is there. Second reason, same, net problem. If you cannot hear, I am wasting my time talking here. Okay, now, this is right now for this sketch. Later, we will consider a strip near the column. There, this BMSF, it will be more severe. Tell me now, I decided to increase these values by what percentage? Tell me. To account for severity under the column, I told you, I will increase by what percentage? I will increase by what percentage? I told you. That is for safer side. Why? This is for the entire width bending. But real bending is more severe under the column. I told a number to you. Next time I will not tell. I told a percentage. Tell how much I told. Safer side. I told a percentage earlier. Later, for safety, because of the severity under the column, I told SFBM, I will increase by some percentage. I told 3-4 times. And if you do by ETABS&SAFE, not required. Why? It will calculate SFBM with the critical effect only, finite element method. There, what you do is, you take a strip under the column. It will give you the severe effect. Clear? In the software, you don't increase. Software, you draw a strip. How to draw a strip, I will tell you. You draw a strip where it is critical. It will finite element method. It will give critical value only. Clear or not? Software, you don't do these things all. Clear? Software, you should not ask, sir, 25%. No. 20. You see that later. If I get in the class 446.2, software will tell around 500. See there. Software will tell around 500. If I tell 800, software will give you 1000. Why? It will consider. Okay. Now, this is clear. Now, here, but later, this bar you will extend up to the column here. That is safer side. See, later we will extend it further, and remaining portion, here top, here bottom, we will give nominal steel. We will give nominal steel. These all we will discuss in the reinforcement detailing. Remember, for ETABS&SAFE batch, very, very important. Later during project, I will not explain. I will tell, go to YouTube class, study and come back. Because why? That's why I told so many things to be explained here regarding detailing. Up to where you have to extend the bar, development length, all will come. Okay, now, one more information. When you design for shear, if you go to ETAB, you move cursor. It will give shear. If you move the cursor, it will tell shear, check for shear post, it will give you. But what you have to do is, if the shear check is passed, if shear reinforcement is not required, check for here shear post of 667, here 799.8. These at the column, two separate shear is there. Critical is this shear, here critical is this shear. Tell me, fully clear? 1 minute. ಆಯ್ತಾಯ್ತು. ಓಕೆ 5 ನಿಮಿಷ. If you want, I switch off one light. Okay, only 5. They are worried because if the inverter goes off, then no power is there in the house. Clear? Okay. Now, I told the problem, power not there. It may come for another maximum 10 minutes, I think. Or it may come for up to 30 minutes. But if I use that 30 minutes, house will be in full darkness till the power comes. So I should be little considerable. So instead of further non-stop we took the class. So I will curtail. Okay, no problem. See, sometimes these are beyond our control. I will curtail because if I continue, because of my personal requirement, house has to go darkness. Not correct. It is someone telling no. No means no. You are telling me don't stop. Someone commented no. I don't know what that no means. No means what? I should not put them in problem. No power. Power may come up. Suddenly the power comes now, no problem. Okay. Now, I will tell you one thing. I will check these values now. I will check now. If wrong, you should check once again and give the answer next time. Agreed? I will check now. Some will tell, how you can check? When uniformly varying load is there, how you can check? You don't bother how I check. I will check. If not telling, I will tell you wrong. Then by next time, you should tell me the revised values here. Agreed? Fast. If agreed, okay. I will check now. How I check? No, don't bother. Hey, Barali. I am not seeing here. See, honestly, actually I can see the answer here. I am not seeing. By depending on S2 divided by intensity 270.32. No, something went wrong. I'll check once again. Oh, I should see shear force here. Okay. It comes to around 0.798 meter. Yes, 0.79 meter. Correct. Okay. One check passed. Second check from that side. Some will tell, why are you seeing post diagram? You don't bother why I am seeing it. It is showing 1 point. I think something went wrong. I check once again. Something went wrong there because so many values are here. Oh, it is a 799.8. See, 799.8. I am not saying that. 1.277 meter. Yes, 1.28 meter. So, you need not bother. These two values are correct. Anybody can tell me how I checked it? I can check this way with the only calculator without writing anything, only if it is UDL. So, today I took it as a UDL of 271 kilonewton per meter, because you know this is almost UDL. Error is so small, therefore I check it. If it is a severe UVL like 200 to 500 here, then I cannot check that way. Then it will take little more time. I should remove that excess load, go to partial UDL case, partial triangle case. Today that triangle part I am ignoring. I am taking UDL. That's why. How some will ask, sir, what is that check? You don't bother. You should learn it by yourself only. No one taught me all those things. Okay. Sorry. around 1 hour early, not 1 hour. Usually, when I take theory on Sunday, I close at 9 o'clock. Why? Non-stop teaching, 10 minutes comes. But around nearly half an hour, I stop earlier for the reason I told you. No problem? Okay. Servant doubt. No time for doubt now. Now, right now, no time for doubt. I saw it late. What is the doubt? You can ask fast. What is the doubt? What is the doubt if you got? You can ask now. I can answer right now. I can ask right now. I never require time for answering. Wait for some time. Wait. Plenty are coming. Brain will go to pieces. Wait. I need time. I got so many commitment. It will come. Wait for some time. Brain will really go to pieces when I tell that one. Wait for some time. I am uploading. I have got lot of commitments. When I am free of commitment, I will make a special class that one. For that purpose only, I will ask the question. Wait for some time. Okay. Thank you. I will close the class now. Next week I will take class from Bangalore only. So no power problem, no UPS problem or no net problem. Why? Wi-Fi is there. Here Wi-Fi is there, but unpredictable. There Wi-Fi is okay, quite good. Okay, close now.